problem 8.4.3. We need to determine the Pade approximation of degree 5 with n equals to 2, m equals to 3 for this polynomial, or for this function e to the x. So this n equals 2 means the numerator degree should be 2, denominator degree should be 3. So we first recall the Maclaurin expansion for this f of x, which is just the expansion, Taylor expansion of this f at point 0. So that's just giving us this. And now remember that this the case derivative of this function and evaluate at 0. So remember that it's e to the x. So you take the derivative for no matter how many times you want. It's just always giving you e to the x. Then you evaluate x at x equal to 0. So that's just always equal to 1. So that's why this is just always equal to 1 here. So that's the Maclaurin series for this function. On the other hand, we need to construct a rational function. Rational function should be just equal to, see here is just r of x, and because the numerator degree should be 2, so that means that we can have this as our numerator, where these p's are to be determined. And for denominator, you're going to be degree 3, so we have, remember the q0 is always 1, then the q1x plus q2x squared plus q3x cubed. So now we just need to take the difference of these two. We want the derivative to be 0. The difference, the derivative, the second derivative after the degree, the fourth derivative. So for that, we just need to get this f minus r, which is going to be f minus. We know that r is it's just p over q, where pq are the polynomial stands for the polynomials. It should be equal to the f q minus p divided by q. So the f is this, the p is this, the q is this. So if we want to show that this one, you take a derivative up to the fourth order, it's always equal to 0. We just need to show that this one, you take a derivative up to the fourth order is equal to 0. But no, by that we just mean that when we expand this numerator, this is the f, this is the q, this is the p. We want that all the terms, so the coefficients for all the terms up to degree 4 should be equal to 0. So when you expand this, you will just have some constant term plus something times x plus something times x squared plus something times x cubed, then plus something times x to the 4th. You want the coefficients for all these terms to be equal to 0. So the coefficients of those, once you expand this, you see that the coefficients for the constant term, which is this, for the term, this is the coefficient multiplied to x, this is the coefficient multiplied to x squared, and to the cube, to the x to the 4th. You want them to be 0. So you eventually have 5 equations, and you can solve for these 5 unknowns, which are the p0, p1, and the q1, q2, q3. So once you solve them, you will get this. These are the values. Remember that q0 is always default to 1. Okay, so that's our rx. That's just this polynomial, this rational function. So this will be our Pade approximation to this function at point 0.